Section 1.1 is on angles, degrees, and special right triangles. So for this first part, angles in general. An angle is formed by two rays with the same endpoint, which is called the vertex. So if we draw that, this would be our endpoint, and then rays, remember, go in one direction. And this would be our vertex. Another part that you should know is positive and negative angles. When we're measuring our angles, we are always measuring them from the positive x-axis. And if we're going up, that's positive.
Oh my God.
And if we're going down, that's negative. Then we have right angles. Those are 90 degrees. Straight angles are 180 degrees. Remember, the right angles, if that is a right angle, you can't assume it is unless they give you the box or enough information to figure out that it's a right angle. Acute angles are less than 90 degrees. So for acute angle. And then an obtuse angle is more or greater than 90 degrees. But less than 180. So it's in between 90 degrees and 180 degrees. If it's greater than 180 degrees, it's called a reflex angle, but we don't need to know that for this section. Complementary angles, they have a sum of 90 degrees, and then supplementary angles have a sum of 180 degrees. So this is hopefully just review from geometry or your trig unit that you did last year. And now we're just going to go through a few examples. Give the complement and the supplement of each angle. So remember, complement means they add up to 90 degrees, supplement is 180 degrees. So to find the complement, we would take 90 minus 40, and that would give us 50 degrees for our complement. And then for our supplement, we would take 180 minus 40, and that will give us our supplementary angle of 140 degrees. Same thing, complement, we would take 90 minus 110, and for this one, we're going to get negative 20. And then for our supplement, we would take 180 minus 110, and we will get an angle of 70 degrees for our supplementary angle. When you're not given a number, but you're given a variable, we're still going to find our angle the same way. We're going to start with 90 for our complement, and then we're going to subtract our variable. And remember, this symbol is called theta, and we use it a lot in trigonometry. So this one would be 90 minus theta degrees for our complementary angle. And our supplementary angle, we're still going to start with 180, and then we're going to subtract theta. And that would be our supplement. All right. Next, we're going to be talking about some triangles. And again, all of this should hopefully be a review. So our right triangle parts, the side across from the 90-degree angle, remember that is our hypotenuse. And then the other two are called our legs. Okay. So we're going to be doing some Pythagorean theorem, and can only be used with right triangles. And hopefully this is something you've been doing for the past couple of years. For this one, our sides are going to be labeled with lowercase letters, and then angles are labeled with uppercase letters. So we're going to solve for x in the triangle below. So remember, for Pythagorean theorem, it's a squared plus b squared equals c squared. A and b are the legs, so this could be our a value, this can be our b value. C is always the hypotenuse. So for this one, a is going to be x plus 7. And then we're going to have plus x squared equals 13 squared. Now remember, when you have x plus 7 in parentheses squared, that means you're taking x plus 7 times x plus 7. So we are going to have to FOIL that to figure out what it equals. And if we FOIL, we're going to end up with x squared plus 7x plus 7 more x, which is where we get 14x, plus 49. And when you have a problem that looks like this, you're going to want to get everything on the same side of the equation and combine like terms. So I'm going to subtract 169 on both sides and combine my two x squareds. So we're going to get 2x squared plus 14x and 0 to 120. And then we're going to have minus 120 equals 0. Now we're going to want to factor this equation. So if there are any common factors between all three terms, I'm going to want to get rid of that. In this one, I notice that these are all even numbers, so I'm going to divide both sides of my equation by 2. And that will leave me with x squared plus 7x minus 60 equals 0. So we're going to factor this into two sets of parentheses. Because it's an x squared as the first term, we're going to start with x and x. And we need a number that, two numbers that add to be positive 7 and multiply to be negative 60. So we know one's going to be positive and one's going to be negative. So we're going to start thinking of numbers that multiply to be 60. That's, let's see, 1 and 60, 5 and 12, 6 and 10, and 2 and 30. So these are just some of the numbers that multiply together to be 60. We're going to want to look for the one that could have a difference of 7. And you'll notice that 5 and 12 have a difference of 7. They're going to add to be a positive number. So that means the bigger number needs to be positive. So we're going to have x plus 12 and x minus 5. And remember, we are solving for x. So the next thing we're going to do is we're going to put each set of parentheses equal to 0. And then we would solve to get our final answers, that x equals negative 12 or x equals 5. And then we need to go back and make sure this makes sense in our triangle. So we have a side length that is just x. So that tells us x cannot be negative because a side length of a triangle can't be negative. So our final answer is just going to be x equals 5. There you are. Next, we're going to do some with special right triangles. So for this one, the vertical rise of a ski lift is 1,170 feet, and the length of the chairlift is 5,750 feet. To the nearest foot, find the horizontal distance covered by a person riding this lift. Round your answer to the nearest foot. Okay. Oh, I said that twice. For this one, vertical means up and down. So we know that this is going up and down 1,170 feet. So let's start with that. And we know the length of the chairlift is 5,750. And remember, a chairlift, that is the part that's going diagonal. So this is 5,750 feet. And they want us to find the horizontal length. That's what we're looking for. And we can assume that this is a right triangle because vertical and horizontal are perpendicular, which forms a right angle. So they want us to find the horizontal distance. So seeing this, we can use Pythagorean theorem. We have our A and our B, and we have C. So we're going to do 1,170 squared plus x squared equals 5,750 squared. And we can go ahead to our calculator and pull that up to figure out what these numbers are. 1,170 squared plus x squared equals 5,750. Oh. KTIS, whether you're stuck in traffic on 394. And squared equals. Okay. Now we're going to solve for x. So we're going to take that 33 million and we're going to subtract our 1 million. And we're going to get x squared equals 31,693,600. So we need to figure out what just x equals. And remember, when you take the square root, you do get two answers, a positive and negative. So we're rounding to the nearest foot. So we're just going to round this, and we'll have 5,600. And when we round this, we're going to get 30 feet about. Okay. So then we can look at this and see which answers make sense. So x is a horizontal distance. So we're just going to use the positive answer and no negative. Okay, next, we have some special right triangles as well. So we have a 30, 60, 90 triangle. And in any right triangle in which the two acute angles are 30, 60, and 90, the longest side, which is the hypotenuse, is always twice the shortest side, the side opposite of the 30-degree angle. So remember, the shortest side is always across from the smallest angle. So if this is our triangle, we would have a 90-degree, a 30-degree, and a 60-degree angle. And the side of medium length, the side opposite of the 60-degree angle, is always square root of 3 times the shortest side. So in this one, our shortest side is across from 30. That's going to be x. The hypotenuse is always going to be 2 times that length. And then the medium sized side is going to be the square root of 3x, or x square root of 3. And we can use these to help us solve for missing side lengths of a 30, 60, 90 triangle. For example, number 4, it tells us if the shortest side of a triangle is 5, find the other two sides. And they told us that this was a 30, 60, 90. And I'm just going to switch them up so we're not getting used to them in the same spot. They told us the shortest side was 5. That's always going to be across from the 30-degree angle. So our hypotenuse is going to be 2 times 5. And then our medium side is going to be the square root of 3 times 5. So we know our hypotenuse is equal to 10, and our medium leg is equal to 5 square roots of 3. You do want to leave as exact answers for these. You aren't going to want to use your calculator, so make sure you leave them as 5 square root of 3. Our next example. A ladder is leaning against a wall. The top of the ladder is 4 feet above the ground, and the bottom of the ladder makes an angle of 60 degrees with the ground. How long is the ladder, and how far from the wall is the bottom of the ladder? So So let's go ahead and draw our picture. So we have the ladder leaning against a wall, and the top of the ladder is 4 feet above the ground. So that would mean this side is 4 feet. And the bottom of the ladder makes an angle of 60 degrees with the ground. How long is the ladder and how far from the wall is the bottom of the ladder? So we know that this angle is 30 degrees, which makes this x. Our hypotenuse is going to be 2x. And if we're still using those, we know that 4 is equal to x times the square root of 3. So we need to solve for what x equals. And we're going to use this equation. So we know x square root of 3 equals 4. Divide both sides by the square root of 3. And we get x equals 4 over the square root of 3. Now if you remember back to our rules of fractions, we need to rationalize that denominator. So we're going to get 4 square roots of 3 over 3 for x. So we know that's our shortest side. Then we need to multiply that by 2 to get our longest side, which will give us 8 square roots of 3 over 3. And there we go. So this is how we can use those side length ratios for a 30, 60, 90 triangle. All right, we have 2 more examples. If the 2 acute angles in a right triangle are both 45 degrees, then the 2 shorter sides, the legs, are equal, and the longest side, the hypotenuse, is the square root of 2 times as long as the shorter side. That is, if the shorter sides of length t, so say the legs, we know they're congruent or the same, those are t. The long side, the hypotenuse, is going to be the square root of 2t, or t square roots of 2. Wherever you want to put the t, it'll still be correct. So we're going to use this information knowing that both those angles are congruent. So an example, a 10-foot rope connects the top of a tent pole to the ground. So if here is our tent pole, there's a 10-foot rope that's connecting it to the ground. If the rope makes an angle of 45 degrees with the ground, find the length of the tent pole. So this tent pole is going to be vertical, so it's going to be perpendicular to the ground. From that information, we can conclude that this is also 45 degrees. So if we use this setup, our legs are both going to be t, and our hypotenuse is going to be equal to t square roots of 2. We need to figure out what t equals. So we're going to take this equation and we're going to solve for t. So again, we're going to divide both sides by the square root of 2. And we're going to get 10 over the square root of 2 equals t. And just like the last one, we do need to rationalize our answer. And we're going to get 10 square roots of 2 over 2. And then we will simplify if possible. And because the 10 and 2 are both even, we can divide them both by 2. And we would end up with 5 square roots of 2 equals t. And remember, we are not simplifying the 2 that's under the radical sign because that one is underneath that radical, so you can't simplify that with the denominator unless you also had a square root of 2 down there. And that would be our answer. If you have any questions, let me know, and we'll go over some more examples tomorrow in class. Have a good day.